All right, these are problems 1 through 5 on review day number 3. The first one gives us a piecewise function, and it wants to know what is the following are true at x equal 2. So if we look at the original, it's x squared minus 4 over x minus 2 when x is not 2. That can be factored into x plus 2, x minus 2, over x minus 2, and therefore it's not exactly x plus 2, but it's going to look like x plus 2 everywhere except at 2. If you were to put 2 into it, then it would means that the function looks like it should equal 4. Okay? In other words, if we were to look at a picture of this at x equal 2, this function is coming in like this, and it looks like it should equal 4 at that spot. But by definition, it says that at 2 it actually equals 1. So down here at 1, there's a dot there. That's what this function looks like. Therefore, does f have a limit at 2? Absolutely. It looks like it equals 4. The limit would be 4. Is f continuous at 2? No. We have a hole in the graph. It has to jump over, not continuous. And if it's not continuous, then you can't take the derivative there either. So both of those are false. The only one that's true is 1. So hopefully you marked A for that. All right. For the second one, we're given x plus 2y times dy dx equals 2x minus y. So a little different format of how they give us the original. And they want to know what the second derivative at 3, 0 is equal to. So what I think is best here is just let's get it into the format we're used to. Let's go dy dx equals 2x minus y divided by x plus 2y. Okay? That's something we're a little more familiar with. Then we can go ahead and take the second derivative. And in order to do that, we're going to have to do quotient rule. So quotient rule is bottom times derivative of the top, which is 2 minus dy dx, minus top times derivative of the bottom, which is 1 plus 2 dy dx, over bottom squared. All right, now we're going to have to do two things here. We're going to be putting 3, 0 in for x and y, but you'll see that we have this dy dx that's popped up a couple times. So what we're going to do is we're also going to put 3, 0 into dy dx and see what that equaled at 3, 0. So at 3, 0, dy dx equals 2 times 3 minus 0, so 6 over 3 plus 0, 3. So anytime I see dy dx for 3, 0, I'm going to put in 2. Okay? So our second derivative at 3, 0 is going to equal 3 plus 0 times 2 minus 2 minus 2 times 3 minus 0, so 6, times 1 plus 2 times 2, 5, over 3 plus 0 squared. So 3 squared is 9. We end up with negative 30/9, which can reduce to negative 10/3, and that is A. All right. So a little bit of work there. Probably best to get it into the form you're more familiar with and then work from there. You can do it a different way, but I think that's probably the easiest. Then we have this one, which the AP likes these kinds of questions. It says, let f be a function that's continuous from 2 to 4. F of 2 is 10, and f of 4 is 20. So sometimes it's helpful to just kind of get a visual on what they told us here. So basically they said at 2, we're equal to a value of 10, and at 4, we're equal to a value of 20. And that we're continuous. Now, how we get from here to here, we don't know, but we know there's no gaps, there's no holes, there's no breaks. Maybe we go way up and come down, maybe we go down and come up, maybe we get straight there. We don't know, but if I start my pen here, I never leave it off the paper until I get to here. But how I got to there is not told to us, right? So we're asked, which of the following is guaranteed by the intermediate value theorem? So the word intermediate means in between. So when you see intermediate value theorem, they're actually just talking about the values that are in between here. Okay? So first option says that the function equals 13 at least one place between 2 and 4. So if I have to keep my pen on the paper, do I have to equal 13 at some point? Absolutely. I can't skip over 13. I have to equal it somewhere. Okay? So that's definitely true, and that talks about the stuff in between. Does the function have to equal 15 at 3? Do we have to be right in the middle there? Absolutely not. We could go above or below. So that does not have to be true. F attains a maximum on the open interval. So that's trying to say that somewhere before 4 we had a maximum. That's not necessarily true. 4 could be our maximum value. If it had been the closed interval, that would have to be true, but 4 could be our maximum, so that doesn't have to be true. The derivative has to equal 5 at least 1. Now, this would be a mean value theorem, but it's not also guaranteed because for the mean value theorem to work, it has to be continuous and differentiable. We're not told anything about being differentiable. Maybe there's a sharp turn here, so that's not necessarily true either. And the derivative is always positive, meaning that this is always increasing. And again, we're not guaranteed that. Maybe it goes up and comes down. So the only one that has to be true is A. All right, then we get this one, and it gives us an integral of f of 2x equal to 10, and then asks us which of the following is true. Now you notice that they had 2x dx here, and now everything is in terms of t and dt. So they're doing like a u sub, but the substitution this time is they're taking 2x and they're making that equal to t. So that was the first thing you had to see here. All right, then 2 dx would equal dt. So dt divided by 2 equals dx. And now if we go and do the substitution, 6 and 12 are x values. So if I put 6 in for x here, I get 12. If I put 12 in here, I get 24. 2x becomes t. Dx becomes dt divided by 2. So I'm going to take that divided by 2, put it out 1/2. So this is a rewrite of that, and that was equal to 10. So I'll put that equal to 10. And if I multiply by 2, I get the integral from 12 to 24 of f of t dt equals 20. And if I look at my options, that's option B. All right, so it's a U sub, just a little different way to ask the question. All right. And then the last one here says that we're given a graph of f, and we're told f is the integral of g, and they want to know which of the following could be g. All right, so if f is the integral of g, that means the derivative of f is g. So in other words, if I took the derivative of this, I get g. Well, if I look at that, that's just a straight line with a positive slope. So that means g is a positive constant. Again, how do I know that? Because g is the derivative of f. F is this line that has positive slope. So I'm looking for a graph that has a positive constant. And this is a negative constant. These are not constants, they're changing. The only one that's a positive constant was A.